The standard algorithm for adding and subtracting decimals is basically the exact same thing as adding and subtracting whole numbers. The only difference is you have a decimal point. Okay, so I'm going to start easy. We're going to do 20 and 8/100ths. Let's start with addition, because you always start with addition. Plus 2 and 108 thousandths. How about that? Okay, so standard algorithm, just like in addition and subtraction, you have to line up your place values, because that's how this works. You're adding the different places. So in 20, I probably should have lined it up this way first. In 20 and 8/100ths, this is your tens place. This is your ones place. This decimal point, of course, everything to the right of it is going to be less than 1. So now this is your tenths place, and this is your hundredths place. Each of these are going to have an ETHS at the end of it. Okay, so this is your ones place. Here's your decimal point. Then your tenths, hundredths, and thousandths. Alright, so as long as you line these up, you're not lining anything up all the way to the right or all the way to the left. You're lining up place values. So here's my tens. I didn't have anything for the 2 and 108 thousandths because there was no tens place there. There was a tenths for both of these. There was a hundredths for both of these. But the only one that had a thousandths was this number. So you can go ahead and fill in a 0 for the top number. Alright. So now, just like in adding whole numbers, you're going to start all the way to the most right place. Let me switch colors. I don't even know if y'all can see that one. You're going to start in the most right place. In this case, the thousandths place. And you're going to add. So 0 plus 8 is 8. 8 plus 0, again, is 8. 1 plus 0 is 1. 2 plus 0 is 2. And 2 plus 0, again, is 2. So where do I put the decimal? It's easy with addition. You just bring it down. As long as you keep everything lined up, it's going to remain right there where it's lined up at. Because the decimal place isn't going to move over to the ones place or over back a couple places. It's going to stay in the same spot. For instance, let me... Okay, let's say this is our addition problem. So even if you have to round, 2 plus 1 is 3. 9 plus 2, that's 11. So I'm going to put the 1 here, and just like with standard algorithm for addition, you're going to carry the 1 just like you used to. So 11, that's 1, 1, and 1/10 carried over. Or in this case, it's 1/10 and 1, 1 carried over. Now you're going to add these, 3, 4, 5. So just like before, like I said, you're just going to bring down this decimal. As long as you kept them lined up, this decimal is going to go in the same place. Okay, why does this work? Again, it's just like with addition. This is place value. This is 2 ones plus 1 1. Maybe I should use those place value blocks. 2 ones plus no ones. And then this one has 2 tens. Okay, so that's where we got our 22 from. Now we have 1/10. So 1/10 is one little bitty piece of that 1. So we have 1/10 and no tenths. That gives us 1/10. 8/10, no tenths. That gives us, 8 hundredths, 0 hundredths. That gives us 8 hundredths. That's why this works. Again, the answer is deaths, not hundredths. The answer is still place value for why it works. Because as long as you keep each group together and you regroup when you're supposed to, you're going to get the right answer. Okay, so we're going to move on to subtraction, which works the same way. You're just subtracting instead of adding. Okay, so let's do one where I have to regroup. I think I picked 2s and 3s a lot. I don't really mean to. I'm gonna bring it out far. Okay, now I'm gonna make a mistake in this one. Okay, so my mistake here, I did not line up the decimals. Okay, so in standard algorithm for adding and subtracting decimals, it is crucial that you line up correctly with place value. So this, in this problem, is my ones place. Right now, I have it under the thousandths place in the other number. So that's incorrect. This is my ones place, and I know because it's right to the left of the decimal. So this is an incorrect lineup. So let me erase it. And I'm going to write it correctly. And I think this is the number it was. Maybe. Okay. So now, just like with whole number subtraction, you're going to start with the place most to the right. So in this case, it's the 10,000ths. So I have 1 minus, and I don't have a number here. So just like with other numbers, you just add a 0 to the end. So if I had 10, you cannot just add a 0 to that because it makes it 100. That's a completely different number. But the great thing about decimal places, if you have 0.1, that is the same thing as this is still 1/10. This is still 1/10. Still 1/10. Still 0.1. Still 1/10. It's the same thing as if you said 0, 1. This is still 1. That's still 1. Still 1. Still 1. And the reason is because if you add zeros to this side, it's not adding anything to the 1. If you add zeros to this side, it's not adding anything to this 1. Now, if you add zeros before the 1, that is no longer 1/10. That is now 1/10,000th. So where the zeros go does matter, but since we did not have anything in this place, we can just put a 0 there as a placeholder. So 1 minus 0, that's 1. 0 minus 4. So just like in standard algorithm of subtraction, we're going to cross out this 1 and borrow. This becomes a 0. This becomes a 10. Because we're in base 10, even though we're working with decimals, you're still going to take 10 away each time. Because this is your hundredths place, and this is your thousandths place. So we know that there are 10 hundredths and 1,000, just like there are 10 hundredths and a thousandth. Okay, so 10 minus 4 gets 6. 0 minus 2, so we have to borrow another time, and this becomes a 10. 10 minus 2 gives us 8. 1 minus 0 gives us 1. Bring down the decimal just like always. 3 minus 1, that gives you 2. Okay, so it's extremely important in addition and subtraction to line up this decimal. You will not do that for multiplication, it does not matter, but for addition and subtraction it does matter. Because in addition and subtraction, the whole point of standard algorithm is to add up same place values and regroup once you get more than 10 of each place value.